Hi, my name is John again. Welcome to Trigonometry. This time we're going to be looking for the areas of triangles, any type of triangle given the SAS case, the AAS case, and the SSS case. Okay. The formulas are pretty complicated for all three of them, and I'm going to be deriving some of these formulas as we go along. Alright. First of all, let's use the SAS case. The angle is included between the two sides. I'm going to do the derivation of this proof, which isn't too difficult. I'm going to do it just a little bit different than the way the book does it. It should be the same thing. Notice that K, we used the letter K, big K instead of A for area, because we have angles A, B, and C. So some books call it S, some books call it K. I'm going to call it K. Okay. And K can equal 1/2 AB times the sine of C. It can also equal 1/2 BC times the sine of the angle included, which is A. It can also equal 1/2 AC times the sine of the angle in between, which is B. So let's label this A, B, C, and we're going to try to find the area of this. Area, basic area formula is 1/2 the base times your height h. I don't know if you can see that. Yes, you can see that. And your height is located right over here. Let's label this height h is the altitude or the height of that triangle. We know certain situations that according to this angle A right there, we can go, oh, there's little c right here, that's big B right there, and small b, small b and small c, and of course it's little a. So the sine of that angle A is equal to opposite h over hypotenuse, which is c. So using simple the basic definitions is the ratio of the height to the hypotenuse. And solving for h is equal to little c times the sine of that angle A. And we're going to substitute this right into our base right there. That's our base, right? B. Oh, no, that's our B. No, not over here, over here, excuse me. Our base is called B right there. That's our B, our base. So the area is equal to 1/2 times the base, which is B, times C times the sine of A. It's a very easy proof. It's one of these three, 1/2 BC sine of A, 1/2 BC sine of the angle included in between. So when you have the SAS case, the side and the included angle between the two sides, then you're always going to be using 1/2 BC sine of A, or these three different ones. They're derivations of the first one, or the second one, or the third one. Okay. So there you have it. We're going to do an example of the law of sines. I'm going to do the one in the book. Example number 1. It says that angle A is equal to 35.1 degrees. Little b is equal to 2.43 centimeters. And little c is equal to 3.57 centimeters. Let's draw it out again. A is 35.1 degrees. That's A. Little a we don't know. We don't really care about it. Little b is located right here. It's equal to 2.43. That's big B. And little big C is right here, 3.57. We really didn't need to draw it out. We just used the formula. The area is equal to 1/2 BC, B times C times the sine of the angle in between, A. Notice it is the SAS situation. So the area, K is equal to 1/2 times B, which is 2.43 times 3.57 times the sine of 35.1 degrees. I'm going to use our calculator to figure that out. 0.5 times 2.43 times the 3.57 sine of 35.1. And it comes out to be 2.49. There it is right there. So the area is equal to 2.49 centimeters squared. Every area is in square centimeters. So when you have the SAS situation, guys, again, the angle between the two sides, you're going to use a simple formula. Two angles one side, you're going to actually use the law of sines and then substitute. So when we have the angle side situation, you're going to use the law of sines, substitute it into 1/2 AB sine of C, and you end up with a pretty complicated formula. I don't like to use this formula just due to the fact I use K's again. Due to the fact that it's kind of complicated, but if you guys want to memorize it, it's not a pretty hard formula to memorize. I personally did not memorize this because I like to substitute the law of sines and actually worked it out using law of sines. C squared is times the sine of the angle A times the sine of angle B over 2 times the sine of angle C. You can figure out, since they gave you two angles, you can figure out the third angle relatively easy, and they give you the side, so it shouldn't be too difficult to figure out. Okay, I'm not going to do this example number 2 for you. Let's get to the three sides situation, the SSS case. It's called Heron's formula. Some books actually calls it Hero's formula. I have no idea why. I've actually seen one book called it Hero's formula. But here's Heron's formula. K is equal to the square root of S times S minus A times S minus B times S minus C, where S is equal to A plus B plus C divided by 2. It's a really complicated formula, as you can see right over here. I'll give you an easy way to memorize this. This portion right over here, A plus B plus C, that's your perimeter of the triangle. A plus B plus C, little a plus B plus C is the perimeter. If you divide that by 2, that's called the semi-perimeter. So it's a semi-perimeter times the semi-perimeter minus the first length, second length, and the third length. So that's an easy way, a little bit easier way to work out this formula. Proof is a little bit difficult, lots of algebraic manipulation. I actually proved this out a long time ago once. It wasn't too hard. It just took like 15 minutes of our time, so I really don't like to do this proof. I'd rather do an example for you to make sure that you understand how it works. Let's use this example here. Example 3. Find the area of the triangle given little a is equal to 12. They use meters this time. Very good. B is equal to 14 meters. And little c is equal to 8 meters. Okay. The perimeter is equal to, that's 20, 34. The semi-perimeter is equal to 34 divided by 2, which is 17. So the area is equal to the square root of 17 times 17 minus 2, 12, excuse me, times 17 minus 14 times 17 minus 8. The area is equal to square root of 17 times 5 times 3 times 17 minus 12, that's 5, 17 minus 8, that's 7. Use my calculator. Get the square root of 17 times 3 times 7, and I get approximately 17. let's look at this. 17 times, did I do the problem wrong? It's 8. 17 minus 8. Oh, that's 9. Oops. Oh, 15 minus 8 is 7. So I use the entry key and I put a 9 instead. I get 17 square root of 17 times 5 times 3 times 9, which is approximately 47.9. Two significant digits, so it's going to be approximately 48 square meters. And so, here it is right here. Okay, sorry, it should have been 9 instead of 7. I'm going to multiply by 17 at this stage. Okay, so 17 times 5 times 3 times 9 is approximately 48 centimeters, and that should be good enough for you to do some of these problems. Good luck on your homework, and this section is pretty simple to use, as long as you have the formulas down. Thanks.